So here's our pre-calculus problem of the day. So we're getting into logarithms in this problem. And so logarithms probably can, when you're first learning them and introducing them, can seem a little bit, I guess abstract or kind of out of nowhere. Like, what does that even mean? What is a logarithm? So the most basic arithmetic operations that we have and that you learn in elementary school, especially these first two, we have addition, we have multiplication, and then the next one you learn at some point in elementary school is exponents. Now, of course, you also learn subtraction and division, but subtraction is just the inverse of addition, which of course you know that. And division, of course, is the inverse of multiplication. Now, what is the inverse of an exponent? You might think it's a root, like a square root is the inverse of a square, but not exactly. A radical or a root, the cube root, the square root, etc., those are actually still exponents. They're just fractional exponents. So the actual inverse of an exponent is a logarithm. And so that, if you remember that, I think it might help at least get the wheels going a little bit. And help you kind of understand why these things are set up the way they are. Um, because it can be a little bit, it just may seem a little bit arbitrary how, why is this logarithm equal to that and so on. Um, and so the logarithm rule is if we have log base a of x equals y, and here a is positive and a is not equal to 1. This is the same, so this is bidirectional, you can go either direction. This is the same as a to the y equals x. And so we call a here the base. And you probably already know, because we've been talking about exponential functions, and you kind of know about exponents anyway. The a to the y here, the a is called the base. And so these are the same. So the base is the base. And then if you're rearranging these, which we're going to do here in these two problems, the way I kind of remember this is, and tell people to remember it if you're just going to kind of memorize this, the base is the base, and then the x and the y are going to switch sides. So here the x is on the same side as the a, here the y is on the same side as the a. So that's a fairly easy way to remember it. Then now, what does this mean? This log base a of x is actually the exponent we need to raise a to equal x. So, kind of keeping those relationships in mind, the exponents and the logarithms can help. And also, if you remember from when we talked about exponential functions, the rule for a was that a had to be greater than 0 and a could not be equal to 1. So for the same reason, we had the same rules for a here. And they're inverse functions, so they need to have the same rule. So essentially what we're doing here, log base 5 of 1 over 125 is we need to write this as an exponential equation. And so 5 is the base, and then we're going to switch these two over here. So 5 to the negative third equals 1 over 125. Then you can check these. As long as there are no variables, you can check these to make sure you're doing it right. And you can make sure that that is actually equivalent, and it is. Then for this one, again, 8 is the base, and then we're going to switch the 2/3 and the 4, and so we get that. Now, some calculators will do this calculation for you. So like I said, you can check this to see if that does equal, well, we know that it equals -3, but you can also check to see if that's correct. But when we're doing these calculations for logs, you cannot necessarily do log base 5 of 1 over 125 in the calculator. Most calculators will only work with a base 10 or a base e, which is the natural logarithm. So if your calculator does not work with any base, then one thing you can do is you can use the log button, um, and just put log of, in this case, 1 over 125, and then divide it by a log of whatever the base is. And so that's called a change of base formula. So you can write this expression as any base that you want. But if you're wanting to calculate these things, typically you need, so this would be a base 10, but we don't write the 10. And you can do that in the calculator. So if you ever need it, probably will at some point, then that's how you do that. So if you have any questions or comments, any other problems you want me to do, then feel free to ask.